Okay, we should be live. Everything we do is on BioniChaos.com. Go check out the website. All the source code is there. I get a lot of questions about the source code. Well, it's on the page. It's on the site itself, considering we're trying to do JavaScript, vanilla JavaScript. So, what do you see on the screen?
I see a web page with the words Prosthetic Arm Interactive Simulation at the top. Below that, there's a diagram of a robotic arm, and on the right side, there are sliders for controlling the different joints and metrics for grip force.
What are the demo actions doing? Can you explain real quick?
The demo actions allow you to select a pre-programmed action for the robotic arm to perform. In the video, it is set to wave.
How about now?
The Grip Show demo action makes the robotic arm open and close its gripper, as if it's demonstrating its gripping function.
Any issues with this web application? Do you have any questions?
There doesn't seem to be any obvious issues with the web application. The simulation appears to be running correctly, and the controls are visible and functional.
Can you ask questions as if you were a data scientist interested in biomedical engineering?
Considering the data provided on the screen, I'm curious about the relationship between the joint controls and the resulting grip force and end effector position. Are there correlations to be explored between these variables in different demo actions?
Okay, is it related to the fact we can control them manually or something? Yes, there's a procedural animation between them, I would imagine. We can dive into the code, but what do you think?
It's highly likely that the manual control sliders directly influence the procedural animation and movement of the robotic arm, as indicated by the changes in grip force and end effector position. Analyzing the code could reveal the specific mappings and algorithms used to translate the slider values into joint movements. We could also explore data analysis techniques to better understand the relationship between these inputs and outputs over time.
Why? What specifically would you look for in the code?
If I were analyzing the code, I would look for definitions for the different joint angles and gripper force, how they are being calculated based on the slider values, and how those values are translated into the visual representation of the robotic arm. I would also be interested in where the grip force metric is derived and how it relates to the joint positions. This information would help me understand the underlying model and data generation process.
Can you answer these questions looking at the front page, the demo mode?
In demo mode, the reach demo makes the robotic arm move to a specific point, while the grip show makes it repeatedly open and close its gripper. The joint control sliders and metrics are displayed, but are not interactively controlled by the user during the demo. Instead, they update according to the pre-programmed action.
Now we can control them manually as well, as you can see here.
Yes, in manual mode, you can adjust the sliders for shoulder yaw, elbow pitch, wrist pitch, and gripper to manually control the robotic arm. As you move the sliders, the metrics for grip force and end effector position will update in real time, allowing you to see the impact of your manual control on the arm's performance. This mode provides a direct interface to manipulate the robotic arm for experimentation or specific tasks.
Okay, so what was the original question? Why do you need to look at the code?
The original question was about the relationship between the joint controls and the resulting grip force and end effector position. Looking at the code would help us understand the specific mathematical models and algorithms used to calculate these values, providing deeper insight into the simulation's logic and how the manual controls influence them.
I'm not sure. Do you have another question, or why can't you just answer that question by looking at the front panel? Why do you need the code for that? Yeah, maybe moving on to a better question.
Looking at the front panel gives us a real-time view of the relationship between the control settings and the output metrics, but it doesn't tell us the mathematical formula or logic used to calculate them. To truly understand the relationship and the underlying mechanics, having access to the code would be more beneficial from a data scientist's perspective.
No, we want to stay on the topic. Again, why do you need to look at the code? We're just having a procedural animation, so all the things are connected. Can you explain it yourself and ask a different question, a relevant question, a follow-up question on the same web application?
You're right. The front panel gives us a visual representation of the simulation. However, looking at the code allows us to understand the specific formulas and algorithms that calculate the grip force and end effector position based on the joint controls. For example, it could tell us the weights or limitations applied to each joint to achieve the movements you see. Now, a follow-up question related to the simulation could be, what is the relationship between the elbow pitch slider and the resulting end effector position on the y-axis?
What is the end effector position? Can you explain that?
The end effector refers to the far end of the robotic arm, which is the gripper. The position is given in x, y coordinates in the simulation grid. As you adjust the joint sliders, the arm moves, and the end effector's position changes accordingly, which you can observe in the metrics section. Did that clarify what the end effector position represents?
Okay, yes, and how about the grip force? Can you explain the grip force and how is it being actually measured?
The grip force is the amount of force exerted by the gripper, essentially the strength with which it can grasp an object. In this simulation, it's likely calculated based on the current gripper opening and possibly other factors like joint torques, although the precise calculation method is not visible on the front panel. As you move the gripper slider, you can see the grip force value change, indicating the strength of the grip at that position.
Can you look at what's happening now and explain the grip force in relation to the grip slider?
I can see that as you move the gripper slider to the right, the gripper closes, and the grip force value increases. Conversely, as you move the slider to the left, the gripper opens, and the grip force value decreases, becoming 0 when the gripper is fully open. This suggests a direct relationship between the gripper opening and the amount of force it can apply.
Okay, and is this correct or is this a very rough approximation? Because, I mean, the gripper could be applying force but still open. Can you explain that?
Based on the simulation, the grip force seems to be directly related to how closed the gripper is, with the grip force increasing as the gripper closes. While the simulation provides a visual and numerical representation, without access to the code, it's difficult to determine the precise mathematical model or whether it accounts for other factors like compressibility of an object in the grip. It serves as an educational simulation, demonstrating the basic relationship between gripper opening and grip force. Okay, think of the grip force as the squeezing power of the arm's hand. The higher the number, the tighter it can grab. You can play around with the gripper slider to see how it changes the force. Why not give it a try and explore the other settings too? What else about the robotic arm are you curious about? You can visit the BioniChaos.com/RoboArm site to experiment yourself. You might wonder how the end effector position changes if you adjust all the sliders at once, or what the different demo actions do. Let me know if you have any more questions. This simulation is a neat way to understand how robotic arms work. You can control the shoulder, elbow, wrist, and the gripper to see how they affect the arm's movement and grasping power. It's a simplified model, so it doesn't include all the complexities of a real robotic arm, but it's a good starting point for understanding the basics. You might find it interesting to explore different demo actions and see how they change the arm's movement. What did you think of the simulation? Is there anything specific you would like to try or ask about? That's a great question. Building on the current demo actions, you could add actions like pick up object, where the arm reaches for a specific point, grips, and lifts. Another one would be place object, which reverses that sequence. Maybe a trace path action, where the end effector follows a predefined shape, or even a more complex task like sort objects, requiring multiple pick-and-place movements. These could offer more insights into how robotic arms are used in the real world. What do you think? Would you be interested in trying out some of those features if they were available? So, imagine this simulator as a virtual playground for understanding robotics. You're not just moving sliders, you're controlling a multi-jointed arm, learning how different parts work together. You could ask questions like, how do the coordinates of the end effector change if I only adjust the shoulder? Or what's the maximum grip force I can achieve? It's a chance to learn about mechanical systems firsthand and explore how precise control is achieved in robotics. Feel free to ask any questions you have about the simulator or robotics in general. I suggested adding demo actions like pick up object, place object, trace path, and sort objects. These would make the simulation more realistic and allow users to practice specific robotic tasks. Were there any other recommendations I made? Let's recap what we've explored. We talked about adding demo actions like pick up object, place object, trace path, and sort objects. These would make the simulator more practical and allow you to practice real-world robotic maneuvers. You'd get a better understanding of how precise control is achieved in these systems. It would be a more engaging way to learn about mechanical systems and robotics in general. Going beyond the current simulation, I would enhance it with a full 3D environment. This would allow you to view and manipulate the arm in 3 dimensions, providing a more realistic and intuitive experience. I'd also incorporate a robust physics engine, so the robotic arm interacts with objects realistically, including gravity, friction, and weight distribution. I would want you to feel like you are actually controlling a physical arm. This would also mean expanding the degrees of freedom, allowing for more nuanced and complex movements. Imagine being able to customize the arm's components and see the effects on its performance. That would truly open up new possibilities for learning and experimentation. Imagine stepping into a virtual workshop, ready to experiment with the prosthetic arm yourself. In a 3D environment with realistic physics, you could truly understand how it moves and interacts with objects. You could pick up virtual items, try tracing complex shapes, or even sort different objects. It would be a fun and interactive way to explore the science behind robotics. Why not check out the simulator as is and see what you can do now? The possibilities are endless. Right now, the simulator offers a basic understanding of robotic arm movements. You can experiment with the different joints and see how they affect the arm's position. Think of it as the foundation. Looking forward, we're very excited about potentially expanding it. We're considering adding 3D elements, more realistic physics, and the ability to perform more complex tasks. What part of controlling the arm do you find most interesting so far? It's great you're enjoying it. Building on what's already there, we could add levels with different challenges, like picking up small objects or navigating through an obstacle course. This would make it more dynamic and less static. What kind of challenges would you like to see in the future? So, you're exploring a cool interactive simulator of a robotic arm. You can adjust the sliders to control its different joints and see how it moves. It's a fun way to learn about robotics and how these machines work. Have you tried making the arm do a specific movement yet?
Where to get source code? Yeah, I did mention source code is on the page. Just go onto the link and F12 it, sources, RoboArm. All the source code is in the HTML because it's JavaScript. So all the JavaScript is within the same file. So you can run it anywhere. It's open source. You can run it on your website or anywhere else. Well, you should stick to my website because there will be updates. We will be updating this tool to make it better, potentially 3D. I want to sort this grip force now. Currently it's just fake. It's just based on the grip position. Whereas we could do something else with it, more realistic. If you have any ideas, do let us know. What else? The speed will just control the demo mode. Oh, the more demo actions, so we will be adding more demo actions. Currently we just have the reach, grip, wave. We want to do like a trace. Shall we? Yeah, if you have any specific questions about any of the tools currently available on the website, do let us know. Otherwise, we'll continue to chat to one of the bots. Unfortunately, we rather talk to a human. But humans are really good at pretending being busy. I don't know what they're doing, scrolling TikTok or something. So we will talk to the bot, talk to the bot, talk to the bot. Yeah, we have this ECG segmentation challenge. It's already up and running. Any internship opportunity available in web development domain. I don't do web development. We have bots doing web development for us. So I do take bots as interns. So if you are a bot and you're charging whatever $10, $20 per month, I pretty much tried them all. I had the ChatGPT, Claude, we had the Gemini, then we had the GitHub Copilot. So essentially a combination of all of them. So they are really good interns. Currently we're back to the basic models because they just do the job. They're really good as interns as well. So we're using Claude Sonnet 3.5, Gemini 2.0 Flash, so the older stuff. GPT 4.1, 4.0, A5, GPT 5 Mini, O3 Mini. So we have those accessible to us. So those currently are interns that are working essentially full-time for BioniChaos. Thank you very much. Yeah, humans are just really difficult to manage, unfortunately. And fortunately we have bots. And you should be using bots as well to develop your projects. Just start a company. Whenever get investors, the whole lot, the bot can do it all for you, I would imagine. So trying to fix, the HTML. Yeah, we have all these prompts, predetermined stuff that just does everything for us. You know, all the intern stuff. You know, editing HTML, front end, panels, size. Make sure it's working on, we have all these prompts, make sure it's working on any screen size, make sure it's working on mobile, make sure it's working on touch screen. So we haven't tested this one yet. You want to start the internship, you can start right now by testing this. later I can get one of the bots to issue you a certificate, like saying, you know, BioniChaos did an internship for BioniChaos testing whatever, RoboArm or another tool. There's a lot of things for you to test. You can start straight away, as far as I'm concerned. Just need the prompts for fixing it. I mean, we can get the bots to test it as well, right? Yeah, we can use Gemini like that. But we still face just adding the standard like SEO stuff, whatever, description, keywords, stuff like that. The Google ads, running Google ads. Apologies for that. If you're seeing too many ads, address your questions to Google. If you just want to gain experience and you don't need money, well, just become a YouTuber. It gives you exposure, can showcase your skills, so on and so forth, and you can start straight away without any minimal bureaucracy and stuff. Because yeah, I have an allergy to bureaucracy, so I'm not doing any of that. I think once you mention like internships and stuff, the YouTube algorithm is perking its ears up. It starts recommending your content because that's what everyone's looking for. That's what everyone is looking for. Yeah, once you have in the comment, gain experience, money. Yeah, I'm not talking about that though, unfortunately, so sorry, apologies in advance. We will not be talking about that. Just trying to fix the code. So the source code is on the page. Source code is on the page. The other thing is we normally get the demo mode to start automatically if the user is not interacting with the page for about 10-15 seconds. Okay, this is looks like more like production ready.